Hello everyone. So let's end this thing by, I guess, next 50 minutes. Okay. So we had done till waiting lines. So this is about forecasting. I'll just go through the sums one by one. So these are theories which are, I guess, you can go through it one by one. And yep, just go through the theories one by one. I'm not going through it. I'll maybe go through it personally later. So for the problems, mathematical problems. We have this file. So in this file, these things were not given. I'll do kind of like MA magic. Okay, so these things were given. Now the questions were using a weighted moving average with weights of zero point 0.6, zero point 0.3, and zero point 0.1, and then using simple 3 months moving average and using exponential smoothing. So three kind of things are there. So what to do with 3 months of MA is this, it is given 3 months, so we have to calculate the first three and calculate from the fourth one, right? So for the month of April, we can calculate the average of last three, and this would be the April month's forecast for 3 months, uh, moving average. For the May month, it will be these 3 months, 12, 15, and 11. For June, last 3 months, and same for July. So this is the 3 month moving average. To calculate absolute deviation, we have to just differentiate with what the demand is and what the real forecasted and real demand is. So we cannot calculate before we have forecast. No forecast was there because 3 month means we need 3 months before, and this one we don't know how it is gonna be. And then for weighting moving average, it's basically the same, but we have average value which would be provided in the exam. So generally the highest value is the nearest month. So for weighted moving average, if you see, it's basically the same, just you have to multiply the highest with the recent most, then the next one with the before that, and then the last one with the 12, the first. So after, so if it is 5 months and five values are there, so the highest should be the recent, then it will be in a decreasing order and upwards. So like that, for the second month, this is the recent one with into 0.6, 15 into 0.3, and 11 into 0.1. Like this, you will get this kind of uh, forecasting, and again, just calculate the differences to get the weighting moving actually deviation. And for smoothing, you have to uh, assume that February's forecast is January's actual demand. So that much you have to do assumption, like February should be January's. And after that, what you have to do is, as it is given alpha equals to zero point 0.2, multiply that zero point 0.2 with the value of last month's demand, and 1 minus zero point 0.2 is zero point 0.8. Multiply that with the last month's forecast. So alpha into last month's demand and 1 minus alpha into last month's forecast. That will be the forecast for the next. Yeah, so where was I? So yeah, right, like that you can calculate the this smoothing thing for and forecast for all of it. So one difference is for 3 months moving average and waiting moving average. We need at least 3 months, and we cannot forecast for the first 3 months. And if it is 4 months, then we have to have 4 months. So, but for smoothing, we can calculate it just like for 1 month after the first month only. And for this absolute deviation, same, you can just calculate the differences from the actual to the forecasted. And then these are called, I guess, these are called absolute deviation and mean absolute deviation for something is summation of all of the values. So that is called mean absolute deviation. Mean absolute percentage error is also there where we calculate the percentage deviation by like after calculating the difference divide it by the demand you will get and into 100 then you will get the percentage. Mean square error is basically squaring the difference, not absolute taking the absolute value but the squaring of the differences and then averaging it, and root mean square is root over that value. Now, yep, so using simple linear regression. So this is the formula. It will be, I guess, given. If not given, you can just look at it. Then regression in this table, I think may or may not be given. You have to calculate somehow. If this is given, you can use the formula to calculate B and then put this B value in the last lines like y bar bx. So y bar is basically 21 by 6 and sorry 81 by 6 and x bar is 21 by 6, the average of all of it. And you just put the values here and you will get a also. So you will get the formula like y equals to a plus bx. B is given by this formula where you can see it's some 6 is the number of how many numbers are there, 1 2 3 4 5 6, and xy is, so you have to calculate x and y. If x and y are given, calculate xy and then x square. Okay, so for summation xy, the summation of the xy values, okay, and for summation x into summation y, summation x into summation y. In the lower part, it's summation of x square. So x square is calculated, summation of x square into n and minus summation x whole square, summation x whole square. This is the formula to calculate b, and then you have to calculate the whole equation. Now to calculate the forecast of July, July is the seventh month. Put the value here, and whatever the value you'll get is the forecasted value. Okay, so this is same with the this thing, the first one question. This is also same. So these questions I have looked into it. These are basically same with the this one. If you solve this one, you can solve all the questions here. This sixth one and the first one. So I'll just go through the sixth one. So here the formula is given for 2 years, spring, summer, fall, winter, spring, summer, fall, winter. And 2008 spring we have to forecast. And now what we have to do is this table we have to create. First of all, I think they also wanted 3 season moving average. You can calculate it from the same equation like 3 and then average. Okay, season moving average, I guess we have to do it like this. So here the actual demands are written. This table, I guess we have to remember. Just remember that actual demand. We have to first write seasons year. Average, then we have to calculate the average season demand. So that is by just like calculating the average for spring, calculating the average for summer, fall, and winter. After that, we have to calculate the seasonality factor, which is this value by average of the these four, which we calculated. So that will give you the seasonality factor. Now dividing that with the value, actual demand will give us deseasonalized demand. Okay, so like that we can calculate, and also for this we can calculate all the deseasonalized demand. Now using this deseasonalized demand, we have to do a regression to calculate the other values. So how to do that? The equation we know, right? So we can just put this x, these are the values of the y, and x we have to put. So I have this for solved already. I'll show you guys. Yeah, so this is how we have to do it. We have just copy pasted the values. Now what we have to do is do regression on these values, right? So 277.03311. So if you see this is the values. These are the values. 277.03. I guess if you calculate total, it would be 270. The last value is 578. Okay, these are the values, right? So after that, what you have to do is you can do, and these are the index you have to do from 1 to 12. You can do it like that. So you can do it in couple of ways. If nothing is given, use the same formula xy, this thing, where x is 1 to 12, these values 1 to 12, 1 to 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and y are these values. So we have 8 values, so we'll take 1 to 8 and do a regression equation and calculate the you know b value, which will be 55.78x, and then substitute that value to calculate this a value, which you will get by calculating y bar and x bar and substituting the value of this 55.78 here. So how we can do that is we can do a simple regression also from data analysis. If you do a regression, see, I have taken this list, and for input we have taken this 1 to 8, and if we make a output here, sorry about that. If we want output here, see, we in the regression also the alpha value is beta 1 is 55.78, 55.78x plus a is 210.86, so 867, which is 0.87. So you can do this also. Now using this formula 55.78x 210.87, we can calculate for x equals to 9, x equals to 10. Just put the value x in the x 9, 10, 11, 12 and calculate the deseasonalized forecast. Then after that we have to multiply it with the deseasonalized factors. So 712 into 0.73, because we divided at the beginning to deseasonalize. Now for the seasonalizing factor we have to again multiply it. So after multiplication, these are the values. So these are the actual forecasted values. Okay, so by that you can get the forecasted value. Now I guess this one is also eighth one. I am not doing it right now. Maybe I'll do it later. But this is also pretty much similar, but with some more complication. You can try if you want. Seventh one is same with, I guess, smoothing constant. Using a simple 3 months moving average, which we know, make a forecast for this month. If the 300 units are actually demanded, forecast before the next month, we know that also. Using simple, yeah, we know this problem. Now comes, I guess, after forecasting, aggregate planning. Theory, I'm not going through the theories, just go through the PPT. Okay, yep, this problem, I guess we have a solution for that. I'll just go through that. Theory, so this is the problem, right? So we know we have the demand for all the months. Okay, so we have the demand for all the months and number of working days, material cost per unit, inventory holding cost, marginal cost of stock out, marginal cost of subcontracting, hiring and training, layoff cost, labor hour required, regular time cost, first 8 hours each day 4 hours, and overtime we are not doing, so not needed. Beginning inventory is 400 units, safety stock is 25% of monthly demand. Now what we will do is go through the 3 or 4 strategies which was discussed in the class. Uh, Let me change the color, I guess. Hmm, is this? No. Wow. Really nice. No. Hmm, I guess black would be fine. So yeah, for beginning inventory level 400 is given and demand is also given for each month. Just write it down, the demands for each month. Okay, and number of days of work is given. Okay, so now safety stock is 25% of demand of this month. So if we are calculating for the chase strategy, calculate the 25% of the demand and put down the safety stock values. Okay, just 25% of the B. Now production requirement, how much we have to do. So how we can do that is B is the demand, C is the safety stock. So 2250 is needed and 400 was already there. So 2250 minus 400, 1850 is the production requirement. So B plus C minus A, whatever. Just look at this value. So these are given. I'll just go through by why it's happening. So we have demand of 1800 in the month and 450 we need to have in the ending inventory. So total 12, 2250 is needed and 400 was already there. So we need new production of 1850. Okay. Now safety stock should be our ending inventory because that's what chase strategy follows. So this is the ending inventory. Now this ending inventory will be the beginning inventory of next month. Now we know the beginning inventory, we know the demand forecast, and we know the safety stock. Now 1500 plus 375 is needed, 450 is already there. So 1500 plus 375 minus 450 is 1425, which is needed to be produced. And again, this safety stock is the ending inventory. Or you can say 1425 minus 1425 is produced and 450 was already there. So 450 plus 1425 minus 500 if you do, which is demand. So 450 was the beginning inventory and 1425 is produced. So total is how much? 1875 and the demand is 1500. So how much is left? 375, which will be ending inventory, which always will be the similar with the safety stock in case of chase. Again, this will be the beginning and similarly you can have all the values. Now production hours required, it is given that for each production you need 5 hours. So 1850 is needed to produce. So how much production hour needed into 5? Into 5 similarly do for all of it. Then number of days of work for the month is given. So how many man hour is there in the month per man? So a single man works for 8 hours per month, 22 days are there. So a single employee will do 176 hours of labor. Now 9250 hours are needed to produce this much and 176 hour is done by one single guy. So how many people would be needed? Just divided 9250 by 176, right? And if it is in a point value, just take the upper ceiling because we need people, right? If it is less, then there will be some issue. So you will get this value. Now, similarly for this, 19 into 8 equals 152, 7125 by 152 will be 47. Now, we have to calculate how much workers we have to hire, how much we have to fire, hiring cost, firing cost. So, for chase strategy, we hire and fire, right? So, initially, we'll consider that we have 53 people. Okay. Now, in the system. Now 53 people, after that 6 people are less. So we don't need to hire anyone. Again 17 is less, 32 is 26 less. We don't have to hire. From 26 to 33, we need to hire 7 people. 33 to 54, we need to hire 21 people. Now in January, February, 6 people are less needed. So those 6 people we have to fire. In this 17 people, 47 minus 30, 17 people we have to fire. In these 4 people we need to hire. Now hiring cost and firing cost are given. 200 is hiring cost, 250 is firing cost. Now 7 into 200 is 1400, 21 into 200 is 4200. These are the costs associated with hiring and hiring. And for firing, there will be 250 with the hiring people amount. So this will be the firing amount. And production cost is production requirement is 1850, right? So and per production how much cost is there is given in the problem. So if you see per unit 5 hour is needed per unit, right? And per hour regular cost is $4. So total cost per unit is 5 into 4 20. So production cost is 20 into 1850, like that you can do for the all of it. And if you sum all of it, like 1400, 4200, these three and all of it, then it will be the total cost from the chase strategy. Now, level production or constant workforce strategy, where we we do a constant workforce, like we don't fire anyone, we don't hire anyone, we create a constant workforce and use that. So here we have seen that the total demand is 8,000 and the number of working days are 125, right? And in a single day, 8 hours of work are done, right? So from that we can calculate, and from that we can calculate how much workforce is needed in average. Like 8,000 is the total demand, and per unit 5 hours are needed. So total 8,000 into 5 hours are needed. The total hours needed is 8,000 into 5. And how much workforce, how much working days are there? 125. And each day we work A single guy works 8 hours. So if you calculate it, the value you will get is 40. So this 40 is the constant, workforce we will keep. So this you can write 40, 40, 40, 40. It will always be same. Now, in this, number of working days are also given per month. And if you multiply it, you will get total production hour, how much production hour it is. So now production hour is given. So and each unit needs 5 hours. So how many units will be produced? 7040 by 5, 1408. Now 1408 is produced and 400 is was beginning inventory. So total 1808 is there, and the demand forecasted for the first month was 1800. So how much is left? 8. So this ending inventory will be beginning of February. Now from February also do the same thing, 14 to 19 6080. So 1216 will be produced. 1216 plus 8, 1224 will be there. From that 1500 is needed. So 1216 plus 8 is 1224. 1224 is the amount we have, and the demand is 1500. So there is a deficit, like don't have that much amount what is needed. So minus whatever the value is the ending inventory, and that will be going to the March. And similarly, we have to calculate, and like this, we have to calculate the whole thing. Now, safety stock is given 0.25 of the total, inventory demand. So for 1500, for demand forecast 1800, safety stock is 450. For 1500, 1500 into 0.25, 375, like that you have to calculate. Now the thing is, if we have, these are the safety stock, but if we are keeping more than this value, then there will be a cost associated with it. And if there is a, negative inventory where we have back order, what it is called stock out problem, and we are providing that in the next month, there also will be a fine or a cost associated with it. So that is given and the beginning, that for where it is, inventory holding cost is day $1.5 per unit per month, and marginal cost of stock out is $5 unit per month. So using that, number of back order here is, if the value are negative ending inventory, that is the back order. So 276 and 32. And excess inventory is when the ending inventory is greater than safety stock, which is happening at this point, this point, and here it's both same. So just the difference is excess inventory. Now back order cost is 276 into 5, 30 25, and inventory cost is 1.5 into 187, 445 into 1.5. Now production cost is how much will produce? 1408 into 20. How much will produce in this one? 1216 into 20. So this will be the production cost. So total again we can calculate 1380 plus 160 plus 281 5 and all these values will be the total cost from the workforce energy. Level production or subcontracting. So here uh, again it will be the chase, kind of like chase strategy, but a little bit different. Here 400 again 1800 same, 450 same, production requirement same. These values are same with the chase strategy. Here what you have to look at is where the production requirement is minimum, in which month, and it is April. So in April 850 is needed, right? So now we have to see for in the lowest production month, how many people are needed, right? So if we calculate 850 into 5 is the total, you know, number of needed, and 21 days are there. So into 8 will be the total workforce which is needed, right? I guess it can be less for other also if the numbers are too close. Check for everyone, I'll say. So maybe we have to find this value which is less for which month. So here it is 850 into 5 by 21 into 8. But in some month, if it's 860, and in the below it's like around 30 into 8. Let me calculate this. Yeah, so we have to calculate for all of it, I think. In this scenario, sir didn't think of this situation where it can be different. So let's say in a month the production requirement is 860 and there are 30 days available. Here the W workforce will be lesser than even 25, right? So I think we can do the chase strategy. And yes, so give me 1 minute. Why is this 850 into 5? 850 into 5. Yes. Okay, yeah. So what you can do is you have to do for all of workforce required for this level production subcontracting also. So by doing it, you will get these values, right? 53, 47, 30, 26, 33, 54. Here, what you have to do is take the lowest one. And I think this value will be in between 25 point something will be there, right? 25.5, let's say it's the value. So in case of chess, you have to take the upper ceiling so that there is not no much like excess, like there is more work and no workforce. And for level production, you have to lower it down. So here, if these are 53, 2 point something, we will take 52. Like that, you have to do for the all of the numbers and check what is the lowest. And for that, take the workforce for all months. Now, for all month, there the number of working days are also given. Total production hour you have to just uh, you know calculate by const workforce into number of working days, and in each working days 8 hours are there, so into 8. So you will get this value, right? So after calculating this value, how much is production is happening in-house? We have to calculate. So if it is 4400, how much we are generating in that month, producing in this month by ourselves? 4400 by 5 because one unit takes 5 hours. So 880 is generated by our household in-house production. How much we have to do from subcontracting is how much we need actually 1850, and 880 is we are doing already. So the difference will be we have to do subcontracting. Similarly, 3800 760 we are doing in-house. Total need is 1425. So 665 will do subcontracting like this. You have to calculate for all of it. And then for in-house cost, it is given 20, and subcontracting also it is given 20. It can be different. So calculate it by 880 into 20, 970 into 20, 760 into 20, 665 into 20. And then sum the total cost to calculate the total cost. Overtime we are not doing. Okay. Now come MRP and inventory management. MRP, so aggregate planning is done, I guess. Yeah. MRP, the solution, I think. Yeah. So for MRP, I didn't have the solution. So this is Monish's solution. Let's see. So what we have to do. Okay. So the problem was this one, example one, where demand for meter A, B, and D are given, sub-assembly D, and item on hand inventory, lead time, safety stocks, these things are given. And what are the scheduled order? And this production structure is given where A needs D1 and then A needs C1. And every C1 needs 2 unit of D and B needs 1 C which needs 2 unit of D. Okay, so for the solution part, if you check, I don't know if this whole thing would be provided or we have to create. If we have to create it from scratch, I guess we have to remember these lines, how they are coming, and these weak things also. So in the problem it is given is, yeah, so in the third month's demand, we have to calculate it, right? So I think there were some theory also here. Uh, in the third month requirement, it is given. So we have to have all of it by the end of second month, right? So in the second month, it's eighth week. So we have to get the values ready at the eighth week, which is end of second month as the requirement is in the third month. Now what we have to do is we have to know for the meter A we have to do first, then meter B, then sub assembly C and D we will do. So for the meter A, demand is 1250. Known is 1000 and forecast is 250. So total demand is 1250. Right? Now no scheduling is there for A. On order is 0, nothing. And for the available is 50. On hand inventory is 50. This is 50. Now we have to order, right? So how much we have to order? Okay, this was given, I guess, that order quantity. So it is given that we for A it follows lot for lot. Lot for lot means whatever is needed we will order. So, but how much it takes times to come? 2 week. Lead time is 2 week. So if we need the 1215 eighth week and we have 50, we need more 1200 more in the eighth week. So net requirement is 1200 in the eighth week. So planned order receipt should be 1200 at the eighth week. So on which date we have to order? It should be 2 week before the eighth week, right? So that after 2 week, the product will be in our hand. So the planned order release will be 2 week before eighth week, which is sixth week. Okay. So this is gone for the meter A. For meter B, again, it's 410 known, 60 forecast, so 470. Now 470, again, its lead time is 2 weeks and scheduled receipt is also there of 10 on order on the week 5. So we have to put in the week 5 10 order. So the available balance will be 60, 60, and after this 10 will be added. So the 70 will be new order. Now at the end of the eighth week, we need 470, and this 70 is our in hand. So we have to have more 400. So for 400 in hand for the eighth week, we will have to order 2 week before that. In the sixth week, we will order 400. Okay. Now for the sub-assembly C. In the question, we have seen that for A also we need 1C. For the B also we need 1C. So total, how much C we need? For A we need 1200 and for B we need 400. So total 1600 is the gross requirement. Now projected available balance is given as 35. I guess in hand, yeah, 40, and safety stock is 5, so 35 is in hand, and there is no on order, so no scheduled receipts. Now, but here and there it was lot for lot, like whatever was needed we were ordering. Here it is said that order quantity should be 2000. So any amount is needed, we can order on like 2000 only at a single point. So 35, 35, 35. In the sixth week, 1600 is needed, and its lead time is 1 week. It is given here. So at the sixth week, we need 1600 as gross. So plan order receipt should be at the sixth week 2000 because the net requirement is more than 0. So at the sixth week 435, sorry, yeah, 35 was in hand, 35 was in hand, 35 was in hand. In the sixth week, the gross requirement is 1600. So we have to order. So how much we can order is 2000, right? So 2000 will order, and for that planned order release should be 1 week ago because lead time is 1 week. So now 2000 is ordered, and what was the net requirement? Net requirement was gross requirement minus in hand, which was 1565. So how much is left in hand? 1000 minus 1565, 435 in hand is left. Now it is left in hand for the rest of the lifetime. Now for sub-assembly D, for every C, we know that 2 times of D is needed, right? And now 2000 of C we have to order. So for 2000 of C, we need 4000 of D at that week. And also for every A, differently 1 unit of D is needed, right? So for every A, so for 1200 A, 1200 D also is needed in that week. And for D alone, the demand is known 200 and forecast 70, so 270. So these three are the gross requirement of D. Now projected available balance on hand was 200 and safety stock was 20, so 180 is on hand, and 100 was scheduled in the 4 weeks, so 280 is in our hand. Now after that 400 is needed, right? So how much was the net requirement? 400 minus 280, 3720. Now 3720 is required. We can order only on 5000 quantity. We will order here. So here we need the order. So if here the order is needed, when we will place the order? 1 week before, because the lead time is 1 week. So here will be the order release and here will be the receipt. So 5000 is in our hand and 3720 is requirement. So how much is left? 1280. That is our new in hand. After that, in the next week also 1200 more is needed and 1280 was in our hand. So how much left? 80. Now again in the next week 80, and here 270 is needed. and 80 is in our hand. So what is the deficit? 190, which is our net requirement. For that, we have to place an order 1 week before. So 5,000 again 1 week before, which will come up with the order of 5,000. Now from 5,000, 190 is required. So in hand is 4810. This is the whole thing. I guess that's it. I'm not going through the theories. Now MRP is done and inventory management is left, I guess. Inventory management has one formula that they will give us the cost per unit for understocking. So they'll be giving us the cost per unit of understocking, cost per unit for overstocking, and probability that a unit will not be sold. So we have to maybe calculate one or the other. So the basic theorem is cost per unit of overstocking into probability that a unit will not be sold should always be lesser than or equals to probability of not being probability that a unit will be sold into cost of understocking. And from substituting, this is the basic formula. Just remember it: P less than equals to Cu by Co plus Cu, cost of understocking by cost of overstocking plus understocking. Now in the problem, cost of overstock, the average room rate is $80. So this is the CU, and if room is overbooked, they'll pay additional charge of 80, 200. So this is CO. So P less than equals to the formula you can put. This will give 0.285. Now we know that we just have to that assume that order booking is a normal distribution. Here you can assume this for most of the cases. I guess sir will give only for those cases. And here the p value probability value you have to calculate z inverse, z value. So how you will do that? Inverse, like you know, norm dot case dot inverse. Okay, so in ops we won't have Excel. So sir will provide you the chart from where you have to calculate, see where the 0.285 is and calculate the Z value from the up and side. Just go through one YouTube video for how to calculate Z value from a chart, or sir will provide, I guess, I don't know. So from that, calculate the Z value, and we know Z equals to x minus mu by lambda. This was SMDM term 1, sorry, sigma. And here mu and sigma is given 5 and 3. Just substitute the values. This equals to Z value, what we calculated, and you will get the X value. Now X value is 3.38. Now we don't need that it should get overbooked and we will incur some loss. So just lower it down and the answer will be 3 rooms it should book. Now, yeah, these things were there. I'll not go into how this formulas came. It was too complicated to understand. Only, yeah, there is this annual demand is 1,000, ordering cost is $5 per hour order, holding cost was given, lead time is given, cost per unit is 1250. Now from that, You have to calculate. Okay, these were also there, right? There were some formulas of DL and everything. I'll watch a football match right now. I'll do it later, I guess. Mm. These are basically formulas you have to remember and put. I also don't understand. I didn't understand how these formulas came, but I also don't know if I'll be able to answer it. So the R value. So this concept I remember as much is this is the quantity which is uh, the max quantity. So when the process starts, it will decrease as more product will go down and down. And after a certain point, we have to order so that after the lead time is over, we will provide. So at this point, we'll reorder, and when the order will come to our facility, our product storage should be zero so that we can fill this up again. Again, it will go down, 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 and after a certain point, we have to reorder again so that when it is zero, we can have the total stock. So now how we can have to order is based on two things I can do. It is one is calculating that in this zone how much demand is there and calculate this R value. So how to calculate this R value is D bar into L. So D bar is 1000 is annual demand. So D bar is demand per day, 1000 by 365 and into L. L is lead time. So in 5 days, how much demand is there? We are calculating. So it is 14 units. So when the stock is 14 units, we will again reorder. Okay. Now EOQ. I even don't remember the full form of EOQ. It was something order quantity. The formula is given root over 2 ds by h 2 into d. D is annual demand and S is ordering cost. Okay, okay, yeah, I remember now. So how much we should order at some point that is calculated by EOQ. So at this point, how much we should cost this 90, how we came, this 90 value, how it came. So how much we should order is calculate the annual demand into 2 into ordering cost, which is 5, and divided it by holding cost, how much it takes to hold. So it will give you the efficient value, how much unit you should order, and then you can calculate in from there by substituting the Q star value, and it will give you that a product on an average how much time it stays in your facility, which is 16.42 days, and then total cost you can calculate by adding CD plus TP Q bar start by into S and Q star 2 by H. So if I remember correctly, the total cost is actually cost of order, like 1000 units are needed, you have to order those, right? So 12.5 is per unit cost and 1000. This is the total cost of product. Now 1000 by 90 into 5. 1000 by 90 is product when it is in the in the I guess install. What is install? For okay, this is install. I don't even know what it is. I guess. Mm, okay, it's waiting time or something in the facility. So from that you can do this, and q star by 2 into h, which is 90 by 2 into h, which is basically holding cost somehow, kind of. So just, I don't know, remember the formula and hope for the best. And if you understand, give me a call and teach me how this formula came. I forgot. So this is the total cost. And this was also given that maybe there will be a problem like this is the Q value, and in this sometimes this does not work how we calculated, right? Sometimes it is more elastic, sometimes it is more steep, sometimes not that much steep. So in some point, let's say inventory in our hand is 30 unit, and order 1 is 5 unit, order 2 is 10 unit, and order 3 is 25 unit. So product fill rate is how much we have by how much total we want. So 25 plus that 10 plus 5 is 40, and in hand we have 30. So product fill rate is 75%, and order fill rate is 30 plus 30 is we have, and maximum how many orders we can take. So we can take order 1 and order 2. We cannot take order 3 with right, or we can take order 3 and order 1. We cannot take order 2 then. So only maximum 2 order we can take at a time. So the order fill rate is 2 by 3, which is 16.67%. And the CSL value is 3 by 5. And what is this? I have no idea. Bye bye. Okay, we have more. Oh my God. Okay, I'll do it later.